Today we will mainly be talking about probability. We will cover the basic concepts about probability, the terms like experiment. If you remember, in the video, we talked about experiment, we talked about sample space, we talked about event concepts, we talked about probability function, random variable. We will mainly discuss these as we go further on a different example than the ones that we have shared with you in the videos. And then we will start talking about rules of probability and do some examples on the probability. How do we find the probability of an event? Such kind of examples. Okay, today I'm planning to talk about around like you see 3-4 questions. There are explanations to the questions. 5th question, these are questions from a previous midterm exam. And then there will be conditional probability concept, and we will do some examples on conditional probability concept. And then finally, statistical independence, and we will perform 2 exercises or 2 examples today. Okay, so that's the main flow of today's session. I'm hoping that finally we will be understanding the concept of probability, conditional probability, and statistical independence at the end of the day. Next week, inshallah, we will start talking about total probability, law of total probability, and Bayes' theorem, which are very important, and there are many critical and interesting questions about Bayes' theorem and law of total probability. So this week we will be talking more on the basics. Okay. So there will be no quiz today. I will just go over the materials that we have covered on the video. Starting from next week, we may have quizzes on the spot, and I will tell you like at some point there will be some prepared quizzes, and there will be some other unprepared, just on the spot quizzes. Okay. So I hope you understand the basic idea of experiment. Okay, do you remember what the experiment concept is, guys? Experiment, random experiments. There will be here there will be a randomness in my experiment. Okay, there will be a repeatable process. There will be a well-defined possible outcomes. Okay, so these are the critical items that we need to understand about experiment. Okay, I'm sure in your high school you covered these a lot, but maybe you name them differently. For example, when you roll a die is the singular form of, let me change the color, singular form, and let me change, no, not this one. Not this one. I need to make it a little bit, yes, singular form of dice. Okay, dice is zarlar, okay, couple, more than one die, and die is a singular form. Okay, this is zar, dice, zarlar. Okay, so rolling a die, flipping a coin, choosing a person from a group. Let's say there are resistances, and there are 5k ohm, 10k ohm, 20k ohm, and you are trying to pull one of the resistances, and you try to find out which is the resistance that you might have. So it's a random thing. You are trying to choose from a classroom whether the chosen person will be male or female. Okay, it's a random process, and you can have well-defined possible outcomes. It may be male or female. Flipping a coin, heads or tails. Okay, for example, yazı is like we have yazı and tura. Tura is heads in English. Yazı is tails. Okay, please be careful. At the end we have s. Okay, tails and heads. I have one heads. Okay, bir tura geldi. Okay, one heads. So let us talk about rolling a die experiment. Okay, let's talk about this. Is it a random process? Can we know the outcome for sure when I roll a die? It's not possible, right? It may be, what are the possible outcomes for rolling a die? It may be 1, 2, 3, 4, 5, and 6, right? There are 6 possible outcomes. When I roll a die, any one of them, any one of these, I can have as a possible outcome. These are the possible outcomes, okay? Possible outcomes. Is this a repeatable process? Yes, I can repeat it a couple of times. For example, I can have 2 dice and roll at the same time, or roll a die a couple of times. Okay, I'm rolling a die once, I'm rolling a die twice. So these are experiments, okay? I have a repeatable process, rolling a die, flipping a coin, choosing a person from a classroom. These are random, repeatable, random processes, random experiments, and then they have well-defined possible outcomes. Possible means any one of them is possible, okay? I can have 1 or 2 or 3 or 4 or 5 or 6. Any one of them will be the possible outcome, okay? This is the basic idea behind random experiment, okay? We will use experiment concept, or we may say random experiment, okay? Or we may say, I'm rolling a die. Rolling a die is an experiment, random experiment. Flipping a coin is a random experiment, okay? I hope this part is clear, right? You understood this experiment concept. Now I want you to tell me, write to the chat, what is the sample space for rolling a die? Rolling a die once, okay? I can do it twice or 3 times, but now I'm talking about rolling a die once. What is the sample space? Look at the definition of sample space. The set of all possible outcomes. What is the sample space? Yes, Özlem has the correct answer. It's not only 6, okay? The set of all possible outcomes is 1, 2, 3, 4, 5, 6. This is the list, okay? This is the list or set of all possible outcomes, okay? From 1 to 6. Is that clear, guys? Sample space. For example, what is the sample space when I flip a coin? Flip a coin once. What is the possible outcome? The possible outcomes are heads and tails, right? T and H. What if I choose one person among you, okay? And I would like to see whether that chosen person is a male or female. What are the possible outcomes? Okay, choosing a person and checking the gender, okay? This is my random experiment, male or female. This is my sample space. Is that clear, guys? Sample space, all possible outcomes. What was the experiment? Flipping a coin, choosing a person, rolling a die. Okay, so these are the sample space things that we will be mentioning in this class, so that you will have the general idea. What is event? For example, this is event, and this is the definition of event, a subset of the sample space. Can anybody tell me an example of an event on the rolling a die experiment? Rolling a die once. This is my random experiment. Okay, and all possible outcomes are from 1 to 6. Okay, this is my sample space. What is the event? A subset of the sample space. Can anybody tell me getting even number from the die? Exactly. Oğuzhan got a correct answer. Anybody else? Oğuzhan said even number. Let's say it's an even event, and possible outcomes are 1, 2. What did he say? Even numbers, right? Okay, even numbers means, let me get rid of this, and then, oops. It will be 2, 4, and 6, right? What even numbers? Even numbers. So this is an event. For example, Ahmed Serdar said getting a number which is bigger than 3. What is the, Ahmed Serdar, what is the outcome? What is the event? What does it include? Getting number which are bigger than 3, 4, 5, and 6, right?
Yes,
exactly. Getting only 3 from the dice is also an event. So we understand this event concept, right? Flipping a coin once, and event may be usually when I flip a coin 2 times, event may be like obtaining heads first, obtaining tails first kind of event. A subset of the sample space. What was the sample space? 1 to 6. What is an event? A subset. Okay, this is a kind of big sample space, and this is an event in it. Okay, so it will be 2, 4, and 6. 1, 3, and 5 will be out of this, and the whole thing is sample space, and this is an event. I hope this is clear, right? Let me go to the next definition. It's about probability function or probability value. Okay, can you tell me, again, let's talk about rolling a die experiment, random experiment, rolling a die once. What is the probability of obtaining 1 when I roll a die? What is the probability of obtaining 1?
1 over 6.
1 over 6. Also, probability of obtaining 2, probability of obtaining 3, probability of obtaining 4, and so on. So this is my probability, and I can draw it like this. Obtaining 1, obtaining 2, obtaining 3, obtaining 4, 5, and 6. And what's the value? 1 over 6. Okay, these are my possible outcomes. Possible outcomes. And for each possible outcome, I have a probability. So that's the probability function, probability value. Okay, I hope you got the idea. Again, we will be mentioning these probability density function, probability functions. We will be talking about them in the random variable part in 2 weeks time, inshallah. Okay, so what's the probability of obtaining, let's say my random experiment is flipping a coin 2 times. And what's the probability of obtaining 2 heads? What's the probability of obtaining 2 heads when I flip a coin 2 times? Exactly, 1/4, right? Because the possible outcomes are HH, HT, TH, and TT. Okay, these are sample space. These are all possible outcomes. Okay, and I am interested in the event of having 2 heads. And my probability of obtaining 2 heads is going to be 1 out of 4. 1 out of 4 possible outcomes, right? So I hope, again, easy concept, probability function. Random variable is a little bit different concept, arkadaşlar. I want you to be clear on this, because we will be using random variable concepts very commonly. Random variable, we will call it RV. Okay, random variable is a numerical outcome. Okay, for example, I am flipping a coin 2 times, same, or twice, same problem, same example. I have all possible outcomes, HT, TH, and TT. And I want you to count the number of heads for each outcome. Okay, this is the random variable. Okay, this is one example for the random variable. I am counting the number of heads for each outcome. What is the number of heads for this outcome? 2. What is the number of heads for this outcome? 1. What is the number of heads for this outcome? 1. What is the number of heads for this outcome? 0. Okay, so I will have random variable for this one. It's going to be 2. Now I'm not going to talk about outcomes, but I'm going to talk about the a number related to the outcomes. Okay, a number related to the outcomes. So for example, in this case, HHHT. For example, rolling a die. Example, rolling a die twice. Rolling a die twice. And I want you to determine the random variables for each like total outcome. Okay, total outcome. What are the possible for it die twice getting number, which are exactly, we are talking about the summation of the dies. Okay, so I roll a die. What are the possible things that can come? 1 to 6. I run it again, 1 to 6. What are the possible outcomes as an addition of these, arkadaşlar? What is the minimum number that I can have? It's going to be 2, right? 1, 1. What's the highest number? It's going to be, it will be 12. So the additions, so the outcomes might be 2 to 12, 2, 3, 4, and 5, and 6, and so on. Okay, so these each numbers, okay, to 12. For example, what is the probability of obtaining 2? What is the probability of obtaining 2 as an outcome? Okay, these are the things that we will be talking today. Okay, or in next week's sessions, talking about random variables. What is the probability of obtaining 2? Exactly. What is the probability of obtaining 1 here and 1 here? It will be 1/6 and 1/6. And the probability of obtaining 2 will be 1/36. What's the probability of obtaining 3? There is only one chance, 1 here and 1 here, for obtaining 2, right? For obtaining 2, it will be, the probability will be 1/36. What's the probability of obtaining 3 as the summation? It may be 1 and 2 and 2 and 1, right? So there will be 1, 2 here, 2, 1 here. It will be what, guys? It will be 1/, this is going to be 1/36. This is going to be 1/36. And I will add these and obtain 1/18. Okay, so you should be familiar with these concepts, but this random variable is something that we will be talking about in this course. It will be continuous random variables, discrete random variables, and even like mixed random variables. Okay, but we will mainly focus on continuous and discrete random variables. Continuous random variables will be a kind of the outcome, the probability might be any number that we might have, but discrete random variable, we will have such discrete outcomes and discrete probabilities for each outcome. Okay, so I hope these are the basic terms. We talked about experiments, we talked about sample space, we talked about event, a subset of the sample space, we talked about the probability, how do we find out the probabilities of certain outcomes. Okay, that's the idea. And then random variable is not the possible outcome, but a number which is related to the possible outcome. Okay, a number, it should be a numerical value. Random variable is a numerical value, a number. Okay, random variable is not H, is not T, is not male, female. Okay, it's not those. For example, it's going to be the number of males, it's going to be the number of females that are under this, number of tails, number of this. If I flip a coin, if I roll a die 3 times, the summation of all outcomes, kind of numbers will be our random variables. Okay, so I hope you got the main idea here. Any questions up to now? Any concerns that you might have? I think it's easy at this point, right? So let us continue with the rules of probability. I will have a break in 15 minutes. So let's continue with some examples on rules of probability. So if you remember, for example, we have a class, okay, and there are 20 female students and 30 male students. What is the probability of, when I choose a random person, what's the probability of that person being male? What's the probability of choosing a random person being a male? Okay, it will be 0.6. Okay, the probabilities are not in percentages, but with 0.6. Okay, the probability of choosing a female from the classroom, it will be 0.4. Okay, and male and female are complementary to each other. So the if I add male and females, I will have 1 probability. Okay, these are the components of the whole group. There are 2 classes, there are 2 categories, groups, and when I choose a person from that group, for example, I have a class which has like electrical engineers, we have computer engineers, we have civil engineers and mechanical engineers. And let's say it's a 50 student class and 40 of them is electrical engineering, 3 of them is from computer engineering, 3 of them is from civil engineering, and 4 of them is from mechanical engineering. So the probabilities will be like the EE guys divided by the total number, right? So it will be 40 over 50, which is going to be 0.8. So I'm going to choose a random person from the classroom, which is like majority of it is electrical engineering students, and some of them are from different departments. And I'm choosing a random person and trying to find out what's the probability of choosing an electrical engineering student. Okay, so if I say if there is only 2 categories, then the addition of probability of L and U, this is male and female, for example, probability of male or female, I say or, right? This is or. You know, this is and. This is or. The probability of choosing a male or female student is going to be the probability of choosing a male student and probability of choosing a female student, because or is veya, right? Erkek veya kadın elektrik öğrencisi veya makine öğrencisi. Okay, it's about like addition of 2 things. Or means this can be okay, and this can also be in the class, in this let's say in this probability. But if they are disjoint, that's the case. Like female and male are disjoint groups, or electrical engineering students and computer engineering students. Let's say we have 2 groups, electrical and computer engineering students, but some students may have a double major, right? This is electrical engineering, this is computer engineering, and there will be some double major students. And in order then my my events, like obtaining a student from electrical engineering or obtaining a student from computer engineering, is not disjoint anymore. Okay, disjoint, birbirinden ayrık. Okay, electrical engineering, let's say we don't have any students who are doing double major with electrical engineering and let's say civil engineering, then we will say these are disjoint groups. Okay, if I have this electrical engineering and civil engineering, EE and CE, okay, there is no overlap, there is no person who is doing a double major in both departments. Then this is a disjoint events. These are disjoint events. But if there is a double major student in this situation, like this is electrical engineering students, this is computer engineering students, and there will be some double major students, then this is not disjoint. Okay, so they are not ayrık. They have some overlap. They have some common elements in them. Okay, so in this case, if it is not disjoint, okay, if there is an overlap, then I will say, if I'm trying to find out the probability of N or U, then I'm going to say the probability of L, the probability of electrical engineering, choosing an electrical engineering student, probability of choosing a computer engineering student, minus probability of choosing both electrical and computer engineering, which are double major students. I need to take them out of the whole number, right? So, for example, I have 30 electrical engineering students in this class. Let's say I have 10 computer engineering students in this class, but there are 2 students who are doing double major. What's the probability of choosing a random person from the group, which is like either electrical or computer engineering student? electrical or computer engineering student, right? So I'm gonna say probability of obtaining an electrical engineering student will be like 30, and the classroom, there might be other students also, like civil engineering or mechanical engineering, total 50. Electrical engineering students will be 30 over 50, which is 0.6. Computer engineering students will be 10 over 50, which is 0.2. And the probability of obtaining electrical and computer engineering students will be 2 over 50, which is 0.04. Okay. In order for me to find out the probability of obtaining electrical or computer engineering student, then it will be 0.6 plus 0.2 minus 0.04, which will be equal to 0.76. Okay, I see a hand. Let me check who is, again, I think I did wrong thing here. Okay, is this clear, guys? This joint and disjoint things, we will use this formulation in our experiments right now, in our examples right now. So if two events are disjoint, then I will be able to use this formulation, okay? Because there is no overlap. If there is an overlap, I need to use this. If you remember the Venn diagrams, you can easily use these, okay? Okay, let's move on. And we will talk about an experiment right now and perform several examples on this experiment. We have an experiment that produces a random integer between 1 and 20. Okay, there are codes, there are functions in MATLAB or in other software. You can generate random integers. Okay, so the possible outcomes are 1 to 20, all integers. Okay, the sample space is between 1 and 20. So 1, 2, 3, up to 20. But the probabilities are not necessarily uniform. Okay, maybe I will have more 20s than 1s. I will have more 10s than 12s. Okay, so what does the probability not being uniform, what does it mean? The probabilities are not uniform. What does it mean, guys? Abdul Kadir, what do you think? What does the probabilities are not necessarily uniform? What does it mean? The probabilities are not. Say it again. The probabilities. Let me ask once again. What does the probabilities are not necessarily uniform? Olasılıklar düzgün dağılımlı değil. What does it mean? Each outcome might have a different probability, right?
Yes, hocam.
Yes, that's the main idea. For example, probability of 1 might be 0.1, but probability of 2 might be 0.01. Okay, it might be different. So if it were uniform, guys, if it were uniform, what would be the probability of obtaining 1 if uniform? Alper, if it were uniform, what would be the probability of obtaining 1? I will call you guys. I want you to be around. I hope you're not sleeping. Okay, I'm not taking any attendance, so I'm interested about your being here. Okay, really being here. So Izzet says 5%. So it will be 1 out of 20 possible outcomes, right? It will be 0.05. or 5%. Is that clear, guys? If I ask you, you can turn on your mic or you can type in chat, okay? If you are not comfortable with your mic, okay? Is that clear, guys? If it is uniform, then it should be 1/20. But in this problem, we might have different probabilities for different possible outcomes. So let's go to the first question. I want you to look at and tell me the answer in the chat. What is the question? If the probability of an even number is 0.5, what's the probability of an odd number? Exactly. You are clever, guys. So it's like a number between 1 and 20 is either an even number or an odd number, right? These are, there is no other chance. There is no, they are all integers, so either even or odd. So if the probability of obtaining an even number is 0.6, then probability of obtaining an odd number will be 0.4 because the addition of them should be equal to 1. Okay, probability of E or even or odd is 1. Because are these disjoint, guys? Are these disjoint events or not disjoint events? Obtaining an even number and an odd number is a disjoint event, right? So these are disjoint events. These are disjoint events. Yes, Özlem says we assume that we are in the integer space. Exactly. If it's not the integer, it will be totally different. Okay. You see the problem. A random integer between 1 and 20. Our experiment is about generating or producing random integers between 1 and 20. It will be 1, 2, 3, 4, up to 19 and 20. These are all integers. There is no 3.5. There is no 4.1. Okay. So, did everybody understand this? Probability of obtaining an even number plus probability of obtaining an odd number will be probability of obtaining even number or odd number, which is going to be 1. Okay. And if I know the probability of an even number, it is given, it's going to be 1 minus probability of even number, which is going to be 0.4. Okay. Probability of an odd number is going to be 1 minus probability of an even number. Okay. We are warming up. We are warming up. Let's move on. Is there any question at this point? Any concerns? Any anything that you don't understand? Easy, right? So let's move on to the next question. So let us read the question. Again, I am generating integers between 1 and 20. And probabilities are not uniform probability. Okay. And I have 2 events. What was the definition of events? It was the subspace. Subspace, okay? A subset of the sample space, sorry. Event is a subset of the sample space. Okay, X is a multiple of 2. What are the possible outcomes for event A? Can you write to the chat? What are the possible outcomes for event A? Cansu, can you write on chat? Possible outcomes is a multiple of 2. Yes, Serhat put a correct answer. It will be 2, 4, 6, and so on, 18 and 20, right? So these are possible outcomes for event A. What's the what are the possible outcomes for event B? Hayriye, can you write on chat? What's the possible outcomes for event B? It will be 1, 3, 5, 7, and 9, right? Less than 10 and odd. So are these two events disjoint or not disjoint? These are disjoint events, right? Disjoint events. Because there is no overlap. If there is an overlap, then we say it is not disjoint. Okay? Joint, you know, in Turkish we call it eklem. Disjoint, eklemlenmemiş. Okay? Ortaklık yok. Okay? If there is no overlap, if there is no common elements, then I would say these are disjoint, ayrık sets. Okay? Ayrık events, disjoint events. So here is the question. Probability of A obtaining this is 0.6. Obtaining this is 0.25. What is the probability of, what is A and B? What is A and B? Not or, right? It is and. So it will be event A and event B. Is there a probability of such a situation? The probability of obtaining such a thing is 0, right? Because these are disjoint events, and disjoint events have no common terms, and the probability will be 0. Is that clear, guys? The probability of obtaining A and B is 0. Or if I say A and B is gonna be empty set. Okay, it's gonna be an empty set. The probability is 0. But if I ask what is A and B, then it should be empty set. Is that clear? The difference between probability and outcome? It is right. One of them is empty set. The other one is probability is 0. Okay. I will do this example and then go to the break after this example. Let A, B, and C be the events X is a multiple of 2, 3, and 6. Okay. What is A? It will be 2, 4, 6, and 18, 20. B is 3, 6, 9, and 18. C is 6, 12, 18. Okay. So these are the possible outcomes for events. These are events. Okay, these are possible outcomes. That means a subset of the sample space. What was the sample space? 1 to 20. What is this A? It's a subsample. Okay, it's like the even numbers. This is the even numbers. This is the multiples of 3. This is the multiples of 6. Okay, multiples of 3, multiples of 6. And this is multiples of 2. Okay, what if I know that probability of A is 0.6 and probability of B is 0.3 and probability of C is 0.2? What is the probability of A or B? Can you write the probability of A or B on chat, please? 0.7, right? 0.7. Göktuğ, can you also write, Göktuğ? Can you also write on the chat 0.7? It's going to be 0.7, right, guys? Why? Because if they are not disjoint, it will be probability of A plus probability of B minus probability of A and B. this is or, this is and. Okay, this is because these are not disjoint, right? A and B are not disjoint, right? There are some common elements. For example, 6 is a common element, 12 is a common element, 19, 18 is a common element. So these are, there is a not, this is not a disjoint. These are not disjoint events. These are not disjoint events. I mean A and B. A and B are not disjoint events. So I should use this formulation. P of A is 0.6, P of B is 0.3, and this is 0.3. So probability of A and B is equal to probability of C, and which is equal to 0.2, right? So obtaining multiple of 6 is the intersection, kesişim, intersection of probability of obtaining or the events of obtaining multiples of 2 and multiples of 3, right? Everybody got the idea here, right, guys? So I hope yes.
I don't understand how is PA gonna be 0.6.
It's given in the example. It's given here. You see?
Yeah, but you assume that our sample space is 1 to 20.
Yes, but it's not uniform, right? It's not uniform. The probabilities are not uniform. This is our assumption. Okay?
I forgot this.
Okay. This assumption is true for all questions that we are dealing with right now. Okay.
Okay. Thank you.
Okay. Thank you. Let's have a break until 9:50, and then come back, and we will finish at 10:50, inshallah. Okay. Thank you very much, guys. See you in 7 minutes. Sorry for that. That was the question. Like, class has 50 students, and 20 of them were male students, and 25 of them were brown-eyed students. And the question was, randomly chosen student, I want it to be male and brown-eyed, or brown-eyed, okay, male or brown-eyed, and I want it to be found as the range of possible values. And I said, here is the formulation that I use. Probability of male or brown-eyed is going to be probability of male plus probability of brown-eyed, and then minus probability of male and brown-eyed. So it will be separately an M and B, and then there will be an overlap. It's like a Venn diagram. As I said, this is M, this is B. There will be some overlap here. So if I want to find out the probability of M or B, I'm going to say probability of M plus probability of B minus this one. Okay, that's how I do. So then I decide on how can I find this one, and I say probability of male and B. It may be either 0, that means all brown-eyed students are female. Then it will be the combination or the intersection, kesişim, is going to be 0. So it will be maximum 0.9, the probability of obtaining a male and or the brown-eyed student. It will be 0.9. Male and brown-eyed students can be, the probability of it can be 0.5, because if all the male students are brown-eyed, then the probability of obtaining male and brown-eyed will be 0.4. Then I'm going to say 0.5 plus 0.5 minus 0.4. It will be, these will be canceled out, and I will have 0.5 as my minimum number. So the probability value, which is given here, will be something between 0.5 and 0.9. Okay, that was the question, and I'm going to share these slides with you. So this explanation, you can check it from there. Okay, now there is a question from a previous midterm. Okay, so I want you to look at it and I want you to give me the answer for A. Okay, give me the answer for A, please. Question. All the students couldn't understand that part, so that's why they did wrong. Let me say, if she tries the key at random, discarding those that do not work. Discarding those that do not work. Discard means get away, remove. Okay, discard, remove. Remove those that do not work. What is the probability of that she will open the door on her third try? 1/60. Some people says 1/60. Be careful, please. It's not 1/60. Yes, Kayra Berk says 1/5. It's the correct answer. Mustafa Ahmed, good job. Mustafa Çiğdem, can you tell me how you found it? Is it possible to open your mic? Okay, discarding means removing. Okay, removing. from-
Hocam, can
Yes.
you hear me?
Yes, I can hear you.
Firstly, I thought that I am picking a wrong key in first.
Okay,
So
what's the probability of picking a wrong key?
4/5
4/5. This
times.
is the first try.
Yes.
Times. Yes.
Now I have 4 key and
Okay.
I need to pick wrong key again. So
Okay.
3/4
3
this
over
time.
4 is gonna be the second try. This is the first try, second try. These are all wrong tries. Okay, wrong tries. And the final one will be a
1/3.
correct
Three.
try, right? It will be
Yes.
1/3. This is the third try, and it should be correct one. Wrong key, and correct key. So if I say 4s will go away, 3s will go away, and finally it will be 1/5. Is that clear, guys? There are 4 wrong keys, 1 correct key, but we don't know which one is which. Okay? So choosing the first one being wrong is 4 out of 5. Then I will discard one of the wrong ones. It will go to 3. And how many keys I have? 3 wrong keys and 1 correct key. What's the probability of obtaining a wrong key again in the second try? It will be 3/4. Now, how many keys do I have? 2 wrong keys are gone, so I will have 2 wrong keys and 1 correct key. What's the probability of obtaining the third one being a correct key? It's going to be 1/3. Okay. Can we, Azime Dilek says, Hocam, just can't we say one of the keys is true? But it's not the question, Azime Dilek. You have to be careful. The question is, it's like third try. Okay? It's like third try. It's not like find out. If it were like, what's the probability of obtaining, opening the door in the first try, then it would be 1/5. But I'm asking, what's the probability of obtaining the door on the third try? Do you understand the difference between these two? So if it were first try, then it would be 1/5. If it were second try, what it would be like? What it would be, arkadaşlar? If it were in the second try, not third try, what would be the answer? Again, 1/5, right? So then it will be 4/5 times 1/4. These are gone and 1/5. So the probability of obtaining the correct key in the first or second or third try is always 1/5. Interesting, right?
So that's it. There is a rule for that. So now let's focus on the second part. Now we are not discarding previously tried keys. Okay, not removing, or we call it replacing. Okay, replace. Yani yerine koymak, replacing. We are trying the key and put it back, which is not logical, but that's the question. Okay, we are not discarding the previously tried keys. What is the answer? Please write to chat. Very good. I see some correct answers on the chat. Exactly. So trying the first one is wrong key, 4/5. Second key, again 4/5. And the third key will be the correct one. So it will be 16/125. Right? There are 4 wrong keys out of 5 keys. Again, I put the wrong key back, and then I'm going to choose the wrong key again. It's going to be 4/5 times 1/5 is the correct key. Wrong, wrong, correct. Okay. So this is called replacement. Okay, there is replacement here, and then it will. This is replacement. Here there is no replacement. There is replacement. Geri koymak. Geri koymak. Geri koymamak. Okay. No replacement and replacement. Okay, so I'm skipping the third part. I want you to do it on your own. Let's go to the next question. Here is the question. Another midterm exam question, arkadaşlar, from previous years. A gambler tosses a coin 3 times. Each time a head comes, he gains 2 TL. And each time a tail comes, he loses 3 TL. Suppose that the coin is biased. What does it mean, coin being biased? Or biased coin, what does it mean? Also,
Taraflı değil, değil mi hocam?
it's not going to be fair. It's going to be tricked. Okay? Biased, tricked. Or hileli, as Enes says. Okay? Tricked or biased. So the probability of obtaining heads is P. So it's not 0.5. Normally, obtaining heads would be 1/5, 1/2. Obtaining tails would be 1/2, right? If the probability of obtaining heads is P, what's the probability of obtaining tails?
1 minus P.
1 minus P, right? Exactly. It's going to be 1 minus P. So the question is, assume all that the tosses are independent, okay? So I'm tossing a coin another time. They are all independent from each other. I want you to compute the probability that he does not lose money 3 times, and finally he does not lose money. Okay, I want you to think about this I will give you 1 minute for solving this. These are the possible outcomes. Arkadaşlar, there is no answer like 1/3, 2/3. It should be related to P. Probability of obtaining heads is P. Probability of obtaining T is 1/P, 1 minus P. So it's not 1/2, 2/3. I'm talking about something related to P. Okay, for example, Hüseyin Esad just shared P cubed plus P squared minus P. It should be something like that, okay? I'm not saying that this is correct, but this is how we should understand the question. What does it mean, not losing money? In what situation does the gambler does not lose money? Exactly. He can win 2 times and lose once. Exactly. Very nice. Or he can win 3 times, right? It can also be. So in this case, can he win in heads situation? Can he win?
Yes hocam.
Yes. So let us tick. In this case, head, tail. Can he win? Yes. In this case, head, tail, head. Can he win? Can he become like not losing money? Yes. How about head, tail, tail? No, right? Because there are 2 tails. He will gain 2 TL here, but he will lose 6 TL. So he will lose 4 TL at the end, right? Here, no, yes. So there are 4 cases in which this person can win, will not lose money. Okay, here he will gain 6 TL. Here he will gain 4 minus 3, 1 TL. 1 TL. He will gain again 1 TL here. Okay, these are the gainings. He will lose here. He will lose 4 TL minus 4. He will lose 9 TL. He will lose 4 TL. He will lose 4 TL here. But we are mainly interested in this one, this one, this one, and this one. Okay. Is this part clear, guys? The things that I wrote here, does it make sense? Yes. So let's focus on the probabilities of these situations. What is the probability of obtaining H? What's the probability of obtaining 3 heads? P cubed, right? P cubed. What's the probability of H? P. And they are independent. So I should multiply 3 such P's, right? P of H is P, P of H is P. So I will multiply these and I will get P cubed. Okay, so this part is done. How about this one? What's the probability of obtaining heads, and tails? What's the probability of obtaining heads, and tails? Probability of heads, and tails is going to be P times 1 minus P. Right? It will be probability of heads times probability of heads times probability of T. So this is P, this is P, this is 1 minus P. Are you with me, guys? Are you following what I'm doing? So what is probability of HTH? Heads, tails, heads. What's the probability of that?
It will be the same thing as HHT.
Exactly. Same thing with this one, right? P squared, 1 minus P. So I did that part also. Finally, now I'm going to do this part. What is probability of THH? Again, the same thing, P squared, 1 minus P. 2 heads and 1 tails. 2 heads, 1 tails. 2 heads, 1 tails, right? So what's the final probability that he doesn't lose money? Probability of not losing money is the probability of obtaining heads, plus probability of obtaining heads, tails, plus probability of obtaining heads, heads, plus probability of obtaining tails, heads. What is the final answer, guys? What's the final answer? It will be P cubed. Let me go and this P cubed plus this, and plus this. So finally, P cubed plus 3P squared times 1 minus P. So the final answer is P cubed plus 3P squared 1 minus P. And this is going to be the final answer. Is this clear, guys? Is this clear?
Yes, hocam.
Any questions at this point? So what did I do? I checked all possible outcomes when I flip a coin 3 times. H, H2, T, all the possible outcomes. Then I check for each outcome, do I lose money or gain money? Okay. If I lose money, I just cross it out. I keep the ones that are related to gaining money. Then I started focusing on each of them one by one and found out the probability of each outcome. So H will be P times P times P. How do I do that? Because it is independent. Independent means when I flip a coin once and flip a coin twice, the second time they will be independent from each other. One of them will not affect the other one. Flipping one coin will not affect flipping the second one or third one. Okay. Arkadaşlar, is that clear? We are done with the questions. There are many millions of such questions. I just came up with some of them. You can find many questions in our book. You can find many questions in the probabilitycourse.com. You can find many books, many questions about this concept on your previous test books. So let's continue with our topic here, okay? So I hope you got the main idea, and we will be now talking about conditional probability. Okay, so conditional probability, what does it mean? Conditional probability is about the probability of one event given that another event has occurred. Okay? Probability of one event given that another event has occurred. So given that means we know it. Okay? We know it. So I know that one event has occurred. Now I'm gonna, let's say I have male and female students. Some of them are from electrical engineering, some of them are from mechanical, civil, or computer engineering. And I will say, I know that the student that I have chosen is from electrical engineering. What's the probability of that person being male? Then I should focus on electrical engineering group, right? Then do the calculations. If I say, what's the probability of choosing a random person from a classroom being male, given that this person is from electrical engineering? That's how I put it. Okay. What is the? Let me write a question. What is the probability of randomly choosing a male student, given that he is from EE. What is given? What is the thing that I know? It is from EE, electrical engineering. What is the thing that I'm after? The chosen person being male. Okay. So here, what is B? Probability of obtaining a random person from electrical engineering. What is A? Probability of that person being male. Okay. So I say probability of male being EE will be equal to probability of male student being from electrical engineering divided by all electrical engineering students. Okay, I'm gonna check the all electrical engineering students and find out which one is male. Okay, what's the probability of obtaining a male student? Obtaining a male student from electrical engineering group out of the whole electrical engineering group. Is that part clear, guys? So that's the conditional probability, okay? Conditional, şartlı olasılık. I know one thing beforehand, and now I'm trying to find out another thing related to that, okay? Is that clear? Burak Alper Şahin, is that clear, my friend? Yes? Sure? No? Okay, let's start with a question. I roll a fair die, no trick, no bias, okay? Die means zar, fair, düzgün. Let A be the event that the outcome is an odd number. Okay, that means the outcome is 1, 3, or 5. Let B the event that the outcome is less than or equal to 3. B is this. Okay. Do you understand the events and random experiment? This is the random experiment. Random experiment. There are two events, which is a subset. If I roll a die, what is the sample space? What is the sample space? 1, 2, 3, 4, 5, 6, right? These are the possible outcomes. What is event A? It's a subset of that thing, and it will be odd numbers. Another event, another subset, is going to be B, which is numbers less than or equal to 3. What's the probability of A? What's the probability of A? That means what's the probability of obtaining odd numbers when I roll a die, when I roll a fair die? Exactly, it's going to be 0 point. So there are three elements here. Totally, I have 6 elements. So it will be 1/2. Probability of A will be 1/2. Is that clear? Also, probability of B is 1/2, right, guys? Probability of B is also 1/2. So what's the probability of A given B? Now I want you to write the meaning of probability of A given B in the chat. I want you to write the sentence form, okay? About like odd number being less than or equal to 3 or something like that. I'm not interested in the calculation right now. I'm interested in how you tell me A given B thing. What does it mean? What does the probability of A given B mean? Let us write the formulation. A given B is going to be equal to probability of A intersection B divided by probability of B. I'm not interested in the solution. I'm interested in how you put this in a sentence. Abdulaziz says the probability of an odd number that is less than 3. I want you to use this kind of a sentence. Okay, what's the probability of randomly choosing a male student given that he is from EE? I want you to think in those terms. The probability that you obtain an odd number, given that the probability of obtaining an even number is B. Think about this, Emmanuel, once more. What is the probability of, let us write here. I think you are writing. Knowing that B happened, find the probability of A under this condition. Okay, but I want in a more, not in A, B terms, but in odd number, less than 3 kind of thing, okay? I don't want any A, Bs. I want finally such a thing. What is the probability of, what is A? What is the probability of obtaining, randomly obtaining an odd number, given that the number is less than or equal to 3. When I roll a die, when I roll a fair die. So my question will be, when I roll a fair die, what is the probability of randomly obtaining an odd number, given that the number is less than or equal to 3? You understand, guys?
I don't understand, Hocam.
Yes.
So, why are we using this?
What's that? Say it again, Emmanuel.
I don't understand why we said less than or equal to 3.
You don't understand?
Why we said less than or equal to 3.
Because B event is outcome is less than or equal to 3. B is defined as less than or equal to 3. This is B. And we know
Okay.
that this happened given that, this is given that the number is less than or equal to 3 means B. What is B? The number is less than or equal to 3. Is that clear?
Yes,
Right?
Hocam.
Yes. So then let's do the calculation. What's the probability of obtaining A and B? What is the overlap between these two? What's the probability of overlap? What is probability of A and B? It's going to be how many items are common? 1 and 3 are common, right? These are common between these, and then it will be 2/3, right? Is this correct? 2/3. What is the probability of A and B, guys? A and B means it is going to be an odd number and less than 3. It's not going to be 2/3. It's going to be 2/6, right? It's going to be 1 and 3, A and B, 1 over 1 and 3 less than or equal to 3, and odd number 1 and 3, and the all numbers that I have in hand is like 1, 3, 4, 5, 6. So it's going to be 2 over 6, which is 1 over 3. What is PB? What is the probability of B? We found it as 1 over 2 here. And then finally, B, A given B is going to be equal to 1 over 3 divided by 1 over 2, which is going to be 2 over 3. Is this clear, guys? Is this clear? So I can look at it in those terms. I know that the number is less than or equal to 3. So I focus on this part. Okay, 1, 2, 3. The number is here. But then it is given. Then I'm asking, the outcome is odd. So the outcome, odd outcomes are 1 and 3. So I'm going to say 2 out of 3 will be odd numbers, given that the outcome is less than or equal to 3. Okay, I can do it without formulation, but I want you to get used to using this formulation in solving questions. But on your mind, you can easily solve such questions like that. Okay. Look at, given that part, you know it, it's 1, 3, 2, or 3. Then you go, what is being asked? What's the probability of A? Given that it's B. B is 1, 2, 3. I know it, it's 1, 2, 3. What's the probability of obtaining an odd number out of this 1, 2, 3? It is 2 over 3. Is this clear? Guys? Yes? Can you hear me? Something occurred in my computer.
can hear you.
You can hear me, right? Yes. Is everything clear in this part, guys? Do you need any more explanation on that?
Yes, hocam.
Let's go to the next question. In a group of 100 sports car buyers, 40 bought alarm systems, 30 purchased bucket seats. Bucket seat means like a luxury seat, okay, for sports cars. You can check it online. And 20 purchased an alarm system and bucket seats. If a car buyer chosen at random, bought an alarm system, what is the probability that they also bought bucket seats? What's the probability of, we know that the car buyer chosen at random bought an alarm system, what's the probability that they also bought bucket seats? Now I want you to focus on the question and give me an answer in one minute. Guys, I want you to write the givens, okay? What's the probability of a car buyer buying an alarm system? What's the probability of a car buyer buying an alarm system? What's the probability of a car buyer, randomly chosen car buyer, buying or purchasing a bucket seat? What is the probability of a person having an alarm, buying an alarm system and bucket seat? What's the probability of that? I want you to give me those 3 probabilities. One of them is 40 over 40 over what? 40 over 100. Arkadaşlar benimle misiniz? Emanuel, senin mikrofonun açık. Your microphone is on, so I see some some noise behind. So what's the probability of obtaining a randomly chosen person buying an alarm system? 40 out of 100, 0.4. This is alarm system 40, right? Out of 100. Okay, I don't see any chat things. I want you to give me the probability of, I'm going to give you these, and I want you to tell me what is the probability of B given A. So we know that they have, if a car buyer chosen at random bought an alarm system, so we know that the guys bought an alarm system. And we want to know, did they also, like how many of them, or what's the percentage bought bucket seats? When I know that they also bought an alarm system. So I can see that 20 out of 100 bought both alarm system and bucket seats, 0.2. This is 0.3. Now I want you to perform the formulation. What was the formulation like? B given A is going to be A intersection B divided by PA. This A will go down, okay? This A will go down. If it is A given B, then it's going to be probability of A intersection B divided by probability of B. This B will be down. A will be down, okay? And this part, the intersection part, will be the same. Okay, I want you to give me the final answer. From this, you can say 0.2 divided by 0.4, which is 0.5. So the probability of a randomly chosen person buying a bucket seat, given that he also bought an alarm system, is 0.5. Is this clear, guys? 0.5 is easy. So there are 40 people like that, 30 people like that, and 20 people are in between. It was like 40, 30, and totally there are 100 people. So you add these up, 40 plus 30, 70 minus 20, 50, 50 out of 100 is going to be like, if I know that they bought an alarm system, this is alarm, this is bucket, this is alarm and bucket. So this is how we look at the problem, okay? So we know that the person is in this group, they bought an alarm system. What's the probability of this group? Then I say 20 over 40, okay? You can think in terms of formulation and you can think in terms of logic. Okay, arkadaşlar, everybody is clear? Do you follow me? Anything that you want to ask at this point? No? Let me go to the next question. I'm not going to explain anything at this point. I want you to do the question on your own. It's your time, 1 minute. I want answers from each and every student in this class right now. I want you to send it directly to me, not to everyone, okay? I have a group of people, some of them are male or some of them are female, okay? The people who have pets, like dogs, cats, birds, anything like that, is like out of 1.86 out of 100, 86 of them will have pets, 14 of them will not have pets. Out of 41 males, like or out of 49 males, the 41 of them will have pets, 8 of them will not have pets. Out of 51 girls or women, 45 of them have pets, 6 of them have no pets. What's the probability of a randomly selected person is male, given that they own a pet? We know this. Okay? We know this. We know that they own a pet. So we are in this group. We are here. Okay? They have pets. I know that. What is the randomly selected person? What's the probability of a randomly selected person being male? That's the question. And I see good, correct answers. Harun Rashid, please think about it once more. I'm explaining once again. These are given that people are owning a pet. So here we are here, and I'm interested in the probability of the selected person being male. So what is the number of what's the probability of people owning a pet? Owning a pet, it's 0.86. What's the probability of males with who owns a pet? 0.41. And probability of male given owning a pet is the thing that is asked. I'm going to write probability of male intersection owning a pet divided by probability of owning a pet, which is going to be 0.41 over 0.86, which is 41 over 86. Is this clear, guys? It is like 0.47, something close to half, but less than half. Is this clear? I got some answers from maybe half of the classroom. I hope the others are also with me. Benimlesiniz değil mi arkadaşlar? Diğer grup cevap vermeyenler, bir problem var mı? Anlamadığımız bir nokta var mı? So, it is critical that you have to understand this contingency table. There will be male, female. This contingency table can also be given as a story, okay? Usually I give a story. This man has this, and this female has this. I give a story, and I want you to come up with this table at the end, okay? Then perform the probabilities and conditional probabilities, okay? So, last 5 minutes, and I would like to talk about statistical independence, and then solve a couple of examples and finish, okay? Statistical independence, if events are independently occurring from each other, then we call them, they are independent, okay? It's like not a good explanation or definition, but knowing that B occurred does not change the probability of that A occurred. I'm flipping a coin once, it's tails. Does it affect the probability of obtaining heads in the second trial? No. They are two separate things, right? So what was the problem? Probability of A and B divided by probability of B, right? That's the formulation for conditional probability. So if I say knowing B if knowing B does not affect the probability of A, then A given B is equal to A, right? Probability of A. Probability of A given B is going to be equal to probability of A. Another more common way of doing this is going to be the intersection of two events will be the multiplication of separate events, probabilities of separate events, okay? Probability of A times probability of B will be equal to the probability of A and B. So obtaining two heads, what's the probability of obtaining two heads? Because they are statistically independent, I will say probability of obtaining one head in the first trial is 1/2. In the second trial, 1/2, it will be 1/4. Okay? Obtaining two ones when I roll a die twice, it will be 1/6 in the first, 1/6 in the second one, and I will multiply them, it will be 1/36. Okay? Arkadaşlar sesim geliyor mu? AirPods'umun şarjı bitti.
Geliyor hocam.
Dersimizde
Geliyor hocam.
göre. Peki hadi bir şu soruyu çözelim ve şey yapalım. Events A and B are known to be independent. Okay, PA is 0.5 and PA and B is 0.4. What must PB be?
Hocam
Well,
0.8.
0.8, exactly. So what was the probability of A and B? It was probability of A times probability of B. So if this is 0.4 and this is 0.5, this is X, X will be 0.4 over 0.5, which is going to be 0.8, which is probability of B. Is this clear, guys? So this was something that I just mentioned to you. If these are independent events, then if I multiply the probability of A and B, I should get the probability of A and B. So that's why this is 0.5, this is 0.8. If I multiply them, I will get 0.4. Okay, last question. I want you to focus on the question right now. Toss a fair coin 3 times. Let H1 heads on first toss. I'm tossing a coin 3 times. H1 heads on first toss. And A will be 2 heads total. I want you to find out, the answer is down, but let's not look at it for the moment. Okay, are H1 and A are independent? How do I find this? What's the probability of H1? What's the probability of H1 heads on first toss? I'm flipping a coin 3 times. What's the probability of heads on first toss? It's going to be 1/2, right? 1/2 will be first on. So what are the possible outcomes? H, 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 T, H, T, H, H, T, 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 H, T, H, T, T, H, H. Okay, these are 8 possible outcomes. First heads, 1, 2, 3, 4 out of 8. So it will be 4 out of 8, which is 1/2. What's the probability of A? 2 heads total. Total 2 heads. 1, 2, and 3. There are 2 heads out of 8 possible outcomes. And then I'm going to say probability of A intersection H1. What's the probability of A intersection H1. So heads on first toss and 2 heads total, right? 2 heads total. First head, so it will be 1/2. Out of 4 possible outcomes, 2 of them are 2 heads situation. So it will be 1/2. Then I will check probability of A times probability of H1, whether these are equal to each other. So 1/2, is it 1/2 times 3/8? They are not going to be equal. So these are not independent. Okay, is this clear? I did it very fast. Sorry for that. But if you check that, we know that PA is 0.8 and H1 is this, contains exactly 2 outcomes, HHT and HTH, 2 outcomes with 2 heads. So the probability of having A, given that it's H1 is going to be 1/2. So if you do this form, if you use this formulation, find out the outcome. Okay. So hopefully this was beneficial for all of us. Let me stop recording here.